Everyone, um, welcome to this tutorial on ANSYS. In this lecture or in this tutorial I want to show you how to apply non-uniform distributed load or distributed traction on 2D structure. So in last lecture we had this problem, and actually we didn't have that time to cover this problem. So here I want to show you how to model that problem. So that problem, actually I have, for example, that 2D structure subjected to non-uniform or parabolic shear traction on that side with function of this form. So I would have rectangle or maybe square. The length A is equal to 1, and T here is maximal value of that traction. So I would say we can assume that maybe 2000 or something. Okay. Okay, so let's start with the definition of the element type. So add solid, we would use Q4, okay, and then specify that Q4 as plane stress with thickness, and I will say something about that. Also we would have, because actually we have shear traction, so we need to assign or define surface effect and select that option, 2D structural 153, and don't forget to specify K3 of that element as underlying solid, because actually we need that element just to transfer the traction from the one side to another side, or from the load to the surface of that element. And then okay, then because actually we had defined those as plane stress with thickness, we need to define the real constant for each element. So for the first element, plane element, we would have, for example, I have thickness of 0.5, and another set for that element also 0.5, but at first point and at the second point. Then okay. So we have done with that. Then definition of the material models: structural, linear, elastic, isotropic. We can assume that as 210 E6 and then 0.3, anything. Then okay. Then okay. As I said, we don't have any sections to define here, because actually we will define the section from the real constant and from the geometry. So from the geometry, let's say we have rectangle or square with length A. So we have area rectangle by two corners. So the first point is 0, 0, and the second corner, or the width of 1 and the height of 1. Then okay. Then we need to measure this. So from meshing, just be sure that you are using the plane element, not the surface element. So from default attributes, go there and check that, and also check that you are using the real constant set number correctly. Then mesh tool. So I would use mapped mesh, not free mesh. I would use mapped mesh, and to use the mapped mesh, we have to discretize the lines first and then mesh the area. So we have to set lines, select those lines, and I would select maybe only element for each line. Then okay, then mesh tool, mesh, select everything, all, and I would have 20 elements for each side. Okay. Then what? Then we need something here, as I said, to transfer the load to that surface of that square. So we need to change that from plane to surface and real constant of 2, and then go back to modeling, elements, surface and contact, general surface, and then no extra node. Select that box and then select all of these nodes and then OK. Now I already assigned at that face or at that line some surface elements. To check that, you can actually go there from list elements, node and attributes. If you see here, so real constant is 1 and type is 1. If you go there, if you go down there, you would see real constant of 2 and type 2. Okay, so now actually you have two defined two set of elements, different elements. Okay, so then actually we need to specify the boundary condition. So from solution, we have done with the pre-procedure step. So from the solution step, go to define loads, apply, structural, displacement. I would say I would fix all that line. So on lines, select that line. Okay. Then what? Then I need to define that parabolic load here. Okay. So for that we need to define some function for that load. We don't have any option here to define function, but to define that function from parameter, we should go for parameter menu and then functions and then define that function. So from that menu, or from that window, inside the result box, you have to enter the function form exactly as here. So we would have a 4 times the maximum value of that load. As I said, I would choose that as 2000, and the a squared, which is the 1 squared, and y here is the coordinate of any node here in direction of y starting from 0 to 1. So y here actually a vector of coordinate y. Okay, so we'd have, for example, if I have here 20 node, so the dimension of that is 20 by 1. Okay, starting from 0 to the 1. Okay, so that function is 4 times t over a squared. Okay, then times y. You have to specify that y as capital and inside those brackets. So y, as you see, that becomes red minus 0, then times a minus y. Okay, then that's it. You defined the function. So before close that, you have to save that function. For example, shear function, and then save it, for example, in your anywhere. So I would say in the desktop first, then close it. Then what? We define that function. So we need to upload or reload that function into our model. So from parameter again and function again, read it from file, and we would find that function here, then open. Then ANSYS will ask you to specify some name for that table or for that function, I can choose, for example, shear, and don't play with that, and then specify those constants, t and a. So as I said, t is the maximum value I choose to be 2000, and a is 1 meter. Okay? Okay. Then I defined that load, but I didn't apply that load. So to apply that load, so from pressure on elements box, select those nodes, and then OK. Now apply pressure on element as from existing table, and as I said, if you remember that graph, that picture, that is normal load, which is load key number 1, and that direction is load key number 2. So for that, I would select that to be 2, and I wouldn't change anything here, then OK. Then after that, as you see here, shear, which is the name of that table I defined. So okay. So now I applied that load. If you want to show that load on that figure, in that model, so from load control, symbols, and pressure, not pressure, tangential in direction of x pressure, and face arrows, and then okay. You see here some different color or some different intensity. Okay, so now you define that load. Then you actually can solve it. So solve, solution is done. Then you can actually post processing, plot results, maybe that one, you see, and also any type of stresses also, for example, anything, maybe stresses, bomb message stresses, and then okay. One important thing I want to remind you, and I want to also correct something I said in the last lecture. So any model, you have to check that the applied load and the reaction are equal each other. So for example, from list here, from list results, reaction, solution, I wanna calculate or display the reaction in direction of y, okay? Because actually we have this here, and so the reaction of that should be upward, okay? In direction of y. If we go down there, the total reaction is 665. So how to check that? So we already know that the total value or the resultant of that load is equal to the area of that load, right? So the area of that load is equal to calculator. The area of that load, where is calculator? Okay. 2/3 times the distance is 1, okay, times what? Times the maximum value, which is 2. So 2/3 times 1 times 2000. Okay. So it should be 1333. Okay. That is the total load we should get from such problem. Okay. But ANSYS, when ANSYS solved that problem, the total reaction was 665. So what happened here? Last lecture, one of you asked me about how ANSYS deal with pressure, and I said only on lines. So I need to correct that. And actually ANSYS for 1D elements, yes, pressure on lines, but for 2D elements, the pressure is acting on the area. So for example, here I have 1 meter and thickness of 0.5. So the total area is 0.5 times 1. So total area is 0.5 meters squared. Okay? So what I have here, the pressure here is acting on that area. So for that, what I have here is actually half of the total load that I have here. For that, if I need the same load as I applied here, for example, the same load of 333, so I should apply the double of that parabolic load. Okay, so again, be sure that the total applied load here is equal to what you calculated from the actual problem. Okay, use hand calculation or anything. Okay, so have a good break and see you soon.